Hey, g'day, it's Prezzo here. I'm revisiting an old project that I worked on last year. This is a wood cutting bandsaw that was given to me as scrap, and I repurposed it as a metal cutting bandsaw. And what I did was I geared the motor down to give me the appropriate blade speed for metal cutting. I rebuilt the blade guides, or made them from scratch. I cast new wheels for the slightly thicker blade, and it worked great. I was able to cut this sort of stock with it. This is 3mm thick aluminium sheet, but just recently I had to cut some of this stuff. This is 1mm thick brass sheet, and with that thickness and this blade, the table was setting up a harmonic vibration, and it got so bad that at some point the stock got jammed between the teeth. It stalled the motor. You'd have to stop the machine, wrestle the material out of the blade and start again. And to be fair, this was only designed for wood, but it's a sheet metal pressed table and it doesn't have a lot of strength or rigidity. And to make matters worse, the mounting for the table is also just a pressed steel fitting, and it's one of these ones that allows you to tilt the table. So at the back there's a locking screw and a pivot bolt, and look, it's just too flimsy for the work that I want to do. So this video is about casting a new table from aluminium and a new mounting for the table. So the plan going forward is that I'm not going to worry about being able to tilt the table. I'm just going to have it set horizontal, but I want to incorporate a slot in the table for a mitre fence. So let's have a look at how we're going to go about this. And yeah, it's a casting video. Apparently they're quite rare at the moment. So yeah, enjoy. This is the original table from the saw, and it's roughly 300mm square. And like I said, it's made of a very flimsy sheet metal. So I knew that I would have to replace this with something substantially thicker in cast aluminium. And this was the pattern that I came up with. Now this is smaller, it's only 260mm square, but it's 12mm thick on the edge, and it's 6mm thick in the center. Now, as for the size, I didn't really need to have a big table on this. It's only used for cutting up small pieces of sheet metal, so I was quite okay with reducing the actual area of the top of the table. And if we turn that over, you'll see that there's a 3D printed part here which matches up with the hole centers for that pressed bracket that's on the back of the saw. And this piece here is where we're going to put a slot in the top of the table later on for the mitre fence. This is just to give some local thickness to that area. Now that's all okay, and then I put it onto my faceplate for my lathe. Now this is a 12-inch faceplate, about 305mm. And straight away I realised that I'm going to have a problem here. I've got no way of bolting this down to the faceplate. The size of the pattern covers up nearly all of the slots, and I don't have any existing holes in the casting that I can bolt it down with. And there's a thing called design for manufacture, and what that refers to is that you have to design a part bearing in mind the method you're going to use to manufacture it later. And that's the thing that I overlooked here. So after thinking about it for a while, I realized that I didn't want to have that existing bracket on the saw anyway, so this was probably a bad idea, putting that on there right from the start. So that pattern was going to get scrapped. Now this is what I came up with instead. Now with this one, it's only slightly smaller. This one's 245mm square. Once again, that's enough area for what I want to do on my saw, but you'll see now that I've got these 4 lugs that will be cast with this part, and they allow me to bolt this down to the faceplate and then face the entire top of that table. Now the other thing was that this was a pattern I made to be able to bolt this down to the top of the frame of the saw. This is where the blade will pass through, and this is sized to fit the top of the frame. We'll look at that in a minute. And this is going to give me a much more rigid mounting for the table on the saw. So this is the surface that I've got to work with when I want to be able to bolt this table down to the top of the saw frame. Now it's just made of sheet metal, there's not a lot of thickness there, and that part in itself is a bit of an issue. But when this casting goes in here, and that's how it's going to fit, but I can then bolt this down in say 3 or 4 places, plus put a couple of screws through from this end here, and that in itself is going to stiffen up that whole assembly. And I've then got 3 mounting points for my table. Now that does raise another problem. At some point I'm going to have to be able to drill some holes in this surface here, and because of the access I'm going to have a problem getting a drill bit in there. But I bought one of these little 90-degree drill accessories for a cordless drill, and with a short enough drill bit I believe I can get in there and get those holes done. So yeah, that's the plan. Let's get to it. Don't know whether you can see this, but that part of the pattern has skewed over sideways when I was ramming the sand from the top. So that could be an issue. Okay, now it's ready to go. Oh, that wasn't supposed to happen. There you go, all fixed. Unfortunately, I lost a bit of detail there and there. Probably a bit of roughness around here as well. But I'll go with that. Now let's have a look at the one that I feel most confident about. This is the bracket that fits on the top of the bandsaw frame. Well, straight away I can see one problem. This section here has been displaced when I round up the mould. It's been pushed over sideways, so unfortunately that may not survive, but everything else about that casting is looking good. No. Alright, well that's a complete fail. Obviously there was not enough material in the riser. You can see that's where it was just getting to the point where it was going to start filling the riser, and just not enough material. So that's why all these edges are all rounded over and the big holes. So yeah, that's no good, Mark. You're going to be back here tomorrow. Alright, please be good. Oh, you gotta be kidding me. Oh man. Far out. What am I doing wrong? Right, well here you can see the pain of metal casting. I was doing this yesterday, getting the metal into the mould. It was flowing freely, started to come up the riser. I figured that I'd completely filled the mould cavity, and you break it open and you find this train wreck. Now, I'm doing what was recommended to me. I'm using a narrow diameter sprue, a tapered sprue with a pouring basin, and I enlarged the size of the gate here thinking I could get the metal in there quickly, and clearly it wasn't quick enough. Now, I did check the temperature of the metal. It seemed to be at the correct pouring temperature or a little bit higher than that, but it's simply just freezing off at this point. So I'm going to break the rule about the tapered sprue. I'm going to use a bigger diameter sprue, and I'm just going to try and get the metal in there as quickly as I can. Now if I get some porosity, well, so be it. I'm just going to live with that. And this issue here, I've sort of modified the pattern. I'm hoping I can resolve that problem. So I'm not going to bore you with the details of ramming out the mould. You've seen that. I'm just going to have a go, and I'll show you whether I've been successful or not. So let's hope lucky number 3. Well, I don't know if you noticed how quickly that metal went in there, and yes, I'm not proud of it, but at the end of the day, I need a result. And if this doesn't work, I swear, I'm going to fabricate it out of steel. Alrighty, see what we got. Alright, good casting. Well, I'm happy with that. Cool. Well, there we go. We got there in the end. So this casting, 2 attempts. This casting, 3 attempts. And just like the course of true love, things don't always run smoothly. So what did I learn? Well, firstly, if you're going to make a split pattern like this one, especially one that has a piece that doesn't have a lot of inherent stability, you need to make sure you're looking after that part of the pattern while you're ramming the sand. Now in my case, I just assumed that the pins which hold those pieces together would do their job, but as it turned out, there was enough pressure from the sand as I was ramming this part that made it tip over sideways. Maybe could have used longer pins, but then you might have a problem withdrawing that from the mould. So that's the first thing. But in terms of the casting that I got in the end, I'm really happy with that. There's a little bit of local shrinkage underneath there, but that's going to machine out. That's not a problem. Okay, next thing I've learned, when you're making a pattern like this one, which has impressions underneath, make sure you put a fillet in there as well as draft angle. Now, when I made this pattern, I put a good draft angle on all of these pockets here, but I neglected to put any filler into the fillet around the inside and the corners. And after 2 attempts and having it coming out looking like this, I went back and put the fillet in there. I just sort of ran some polyurethane filler in there and just ran it around with my finger, and lo and behold, fixed the problem. So should have done that right from the get-go, but there you go. Next thing, I guess, if you're doing a big flat casting like this one, it's important you get the metal in there as quickly as possible and make sure it's hot enough. I tried using the tapered sprue and the pouring basin, which worked fine on this one, absolutely perfect, but on this one it failed twice. So in the end, I just used a parallel-sided sprue, about 20 to 25 millimeter diameter. No pouring basin, I just dumped it straight down the hole. But guess what? It worked. These two parts will eventually go together. They'll be bolted together, and this part in turn will be bolted to the frame of the bandsaw. Remember, this is all upside down at the moment. Now in this video, I didn't sugarcoat anything. You saw how frustrated I became trying to make these two parts, but at the end of the day, I did get two usable parts. And I couldn't easily make these two parts any other way. Yes, I could probably fabricate this out of steel, but it would be very heavy, and I have to lift that bandsaw up and down from a cupboard to use it. Same with this part here. If I was to fabricate that, it would end up being chunky and heavy. The aluminium is good for me because it's not only lightweight, but it also has an internal dampening of vibration. So when that's one of the main issues I had with the old table, was that harmonic vibration. It also doesn't corrode. It looks good. It's easy to machine, and for those reasons, casting was the way to go for me. Now, you know, yes, it gets frustrating, but that's part and parcel of making things in the home shop. If you're going to make things, things go wrong. That's just the way it is, and don't let anyone tell you any different. So I'm going to wind up here now. I'm going to invite you to come back and have a look at the metal machining that's going to go on here. It's going to be fun, and for now, it's Prezzo out, and thanks for watching.